For each of the functions below, use Descartes' rule of signs to help determine all of the possible combinations of positive, negative, zero, and imaginary roots that the function can have. Then graph the function on a calculator and put a star next to the combination of roots that's correct based on the graph. I think the very last problem we did the last time was a problem like this. So do y'all have a calculator?
Yes.
Okay. Now you may be thinking, what's the point of doing all this? It's another tool in your toolbox. It's just another thing to help you understand polynomial functions. Remember, Descartes' rule of signs says the maximum number of positive real roots is found by doing what? Sign changes in what? In f of x, right? And the maximum number of negative real roots you will have is found by, right, the number of sign changes in f of the opposite of x. So you find your maximum possible number is 5. How many could the equation have? 5 or 3 or 1 drops by increments of 2. All right. Positive. Sign change? Yes? Sign change? Sign change? All right. So the possible number of positive real roots will be 3. That's the maximum number, or 1. Now let's do the negative. We're going to do f of the opposite of x. We're going to clean that up. Tell me if that's right. If you raise a negative number to an even power, that's going to be a positive, right? So this will stay positive. And for the same reason, this will stay positive. Negative x times negative x is positive x squared. How many sign changes do you see here? None. Goose egg. What's the maximum number of negative real roots this polynomial will have? None. Next question. How many times is 0 a root of this polynomial? Why twice? Right, because you have a GCF of x squared. So 0 is a root twice. We can't say or 0 times because we know it's a root twice. Now let's make a table. And the table's going to go like this: positive, negative, 0, and imaginary. And we had 0 was a root twice. Okay. So let's look at we got to play with the combinations of positives and negatives. If I have 3 positives, I could have how many negatives? None. If I have 1 positive, I could have how many negatives? None. How many times is 0 a root?
Twice.
Period. So how many imaginaries could I have for my first row? Why? Good, because my sum has to be 5 because I have a quintic function. How many imaginary roots for the second row? Good. Now I want you to graph it on your calculator, and let's see which of those scenarios is the real answer. Okay, let's look at number 2. Positive, negative, 0, and imaginary. How many sign changes does P of X have? 3? 3. So the maximum number of positive real zeros will be 3, but it also could have 1. So positive will be 3 or 1. Let's do P of opposite of X. Can you do that in your head? Put the opposite of X in and simplify. That'll stay the same. That'll change. That'll stay the same. That'll change. And that'll stay the same. Which signs will stay the same? The ones with an even exponent? Good. Good. How many sign changes we got here? Okay, so the most negative roots we're going to have is 1, but we could also have 1, right? We don't have any options there. We're going to have 1 negative real root. How many times is 0 a root? Why none? Good, there's no GCF of X to a power. All right, so if I have 3 positive roots, I could have how many negative roots? 1. If I have 1 positive root, I could have how many negative roots? 1. 0 isn't a factor ever, isn't a root ever. First scenario, how many imaginary roots will I have? 1? None? And for the second scenario, okay, graph it and see which one works. Why do you think it's the second one? Does it kind of just look like a parabola opening down? That's kind of what it looks like, even though it's not really a parabola, but that's kind of what it looks like. You see 1 positive real root and 1 negative real root, so that means the other 2 have to be imaginary. You getting the hang of this? I'm just trying to decide if we need to work. Aren't there 5 there? I don't think we need to work all 5, do you? Let's pick one more. 4? Fine. All right, 4. All right, let's do 4. All right. What's the maximum number of positive roots, positive real roots? 1. Let's figure the maximum number of negative real roots. 1. Well, that's pretty simple. Why is 0 a root once? Because I have a GCF of X to the first power. Good. So, well, this is going to be pretty easy. Positive, negative, 0, and imaginary. Huh? Yeah. That's it. That's it. That's habit. My college professors did that, and because it's not alpha character, a letter. I didn't start doing that until I was in college, and all my professors did it. They would make a 7 like that, and they would make a Z like this. Do you? So it wouldn't be considered a 2. These college math professors are just sloppy writers, just really bad. This helps you just when you're trying to sketch a graph, these kind of things can just help you a lot to make sure you got stuff in the general area where it's supposed to be. Really? See, my notes have a whole nother page. Well, and they're, yeah, okay, well, daggum, you guys are finished.
We're such an advanced class.
Boy, I don't even know if this is allowable.